Hello, everyone. My name is Flavio Pereira. I'm part of the technical enablement team in OCI. And today we're going to cover the storage level 200 lesson. On the storage lesson, we're going to cover topics around local NVMe devices, block storage, and file storage service. I'm going to give you some more details about that, how performance works on each one of those layers, how you can apply those type of storage on your workloads, and how you architect the storage to better suit on your application when you're moving that to OCI. So the first portion of this is local NVMe devices. So we're going to talk about local NVMe devices, how we can use it, what the options available inside of OCI to use that, and what kind of performance you can have with local NVMe as well. So just to give an overview, local NVMe is available, of course, in OCI. You can get access to local NVMe based on the shape that you actually deployed inside of OCI. So if you pick one of the dense I/O shapes, so every shape that's called dense I/O will have a local NVMe device associated to it. So those devices are drives associated to the server, so you can get the raw device and then format and put in the file system that you want to, and then use that NVMe to hold your application to actually store all the data that needs high performance and extremely demand I/O. So use cases like big data, HPC will benefit from the local NVMe devices to get the best throughput, I/O, and latency of those devices. Okay, so as you can see, you can go up to 51.8 terabytes of local storage. So you can have one of the shapes, the bare metal shapes can give you up to 51 terabytes of storage. Around 3 million IOPS. So if you combine all the NVMe devices together on one of those bare metal shapes and run some benchmark around the NVMe, you can get up to 3 million IOPS on that. Okay, so just to give an overview, and again, all the shapes with dense I/O on name, you have local NVMe device associated to that. Okay, so one big thing around NVMe is like what happens if that NVMe device fails. So as I mentioned, the NVMe is locally attached to the shape, so it's not something you can deattach the NVMe once you terminated the instance. When you terminated the instance, you actually delete the NVMe device, right? That's not the same as rebooting the instance. If you reboot the instance, all the data will be preserved on NVMe. But if you deleted the instance, all the data inside of that NVMe will go away. Okay, so you have to keep that in mind. If there is any problems with the NVMe device, if for some reason that device fail, the best way to recover and best way to do it is actually launch a second instance of a dense I/O shape and just copy the data over from that server to another one. And of course, make sure you have a backup policy in place. So it's highly recommended that you take backup often of the data that's hosted on top of the NVMe device. So this gives you a layer of protection, and if something went wrong with the shape of the device, you can restore that data in another machine. So keep that in mind. You can do backups of your NVMe device. We highly recommend it to do that. Another thing you have to do is create a software RAID using those NVMe devices. So when you have the NVMe devices, it's all raw devices available. You can create a RAID to protect the data, and then you can go all the way to RAID 10, RAID 1, and to mirror the device. So actually you have this protection in case something went wrong. We can just take out the NVMe device and replace that, and your data in your machine will keep the data in place, right? So the chip will be up and running without any problems. Okay. Of course, there's multiple tools that can help you to make copy and synchronize data from one place to another. For example, you can attach a block volume along with your instance, which hosts the NVMe device, and then rsync the data from the NVMe to the block storage. That's one way to make a copy to it. Of course, you can tar GZ, you can compress the data from the NVMe device and move that over to an object storage if you want. That's one way to do it. and have a copy of that data placed on NVMe. So there's a few options, and then keep in mind if the NVMe device fails, there's a couple ways you can recover, you can get back to your data. But you have to have the premises that you have a backup in place and you have a way to protect the data using the RAID configuration. So here's some of the NVMe performance metrics. This is just a slide showing how much of performance you can get on some of the NVMe's. So if you're looking at that, we're just doing a test in one single NVMe device, running a 50-50 read and write operation using a benchmark tool called that came from Cloud Harmony. So Cloud Harmony provide a benchmark tool. You can access their website. It's a GitHub repo. You can download the tool and execute that on the server. I'm going to go do a quick demo as well and show you how you can do a field command to get similar results around the IOPS here. But as you can see, just show you a graph of 500K IOPS you can get on a read-write operation on NVMe device. So I highly recommend you test it. You can get similar results and understand how powerful is the performance of NVMe devices locally on your machines. This is another example of using a read and write for all the NVMe devices combined. So you have that combined because you can have shapes with multiple devices. You can combine those. You can go all the way up to 3 million IOPS of performance here. Okay, really proud of the performance that we have around NVMe. We offer SLAs on top of it, so you can access the website to get the SLA information on NVMe performance. As you can see on the table, you do have dense I/O shapes, all the dense I/O shapes available today in OCI, and then the amount of minimum supported IOPS you can get. So on a VM dense I/O 1.4, you can get over to 200K IOPS. Okay, so if you want to do similar tests on your own and you want to test it out, you can go on GitHub repository, get the Cloud Harmony benchmark tool, and then execute that against your VM shape. All those were measured against the 4K block sizes, so you can change that to 8K if you're doing other specific tests, so you can see the performance and how that will work for your environment. Okay, we highly recommend you to do some tests so you can get the performance and numbers that you were expecting to. All right, so let me do a quick demo. I'm going to show you how you spin up a VM dense I/O, get access to the NVMe device, how that's going to be presented to you, the operating systems, and how you can operate this device. All right, so I just want to give a quick demo of the VM dense I/O shape, which has NVMe devices associated to it. So I do have one VM on my Oracle account, so I'm logged in on my OCI account here. If I go to compute instances, just go back here real quick, and then I can see I have a couple VM dense IOs that I deploy. One is 2.16 and one is 2.8. So this one has one device, and it one has two devices of NVMe associated to the shape. Again, when you create the instance, you can select the shape, and then you choose the VM dense. Any dense shape will have NVMe associated to the server. So let's go check here real quick. I'm gonna do an SSH to the server, and just do an SSH here. Okay, so this is my VM dense IO 01 machine, and I'm just gonna do sudo su become a root, and then if I install a package, there's a package you can install that's called NVMe CLI. So you can install this package on your operating system, and then if you do NVMe list, you can see the NVMe devices associated to your server. So you see both NVMe's, each one with 6.40 terabytes, so 6.4 terabytes available, so around 12 terabytes associated to this server. So I can create a RAID one based on those disks, then can mirror each other, and then have access to my application based on the RAID device that I created, right? So yeah, this is the device. As you can see, it's a raw device. There's nothing on it. I can just go and format the device and create a partition, put it the file system, and then mount the device inside of my operating system. So it's locally attached. If I do a cat proc partitions, I can see that the NVMe devices are available here as well. All my boot volume on the VM is on the storage side, on the block storage side, and then I have the NVMe devices as an extra disk associated to the VM shape. Okay. So you can install a command called fio. If you do yum install fio, this is a benchmark tool that you can use to verify the performance of your device. I do have that installed on my machine. I'm going to run this fio command right here. I'm just going to get the device name of my NVMe. So dev NVMe 0 and 1. So this is the first device, the first NVMe device. I'm going to create a 10 gig file on the block size of 4K. That's going to do a read and write operations, operation inside of the device, and then it's going to give us the result of the ops. So when I execute that, that's going to take a few minutes here to complete. But you can kind of see it's getting to the performance that we're actually looking for. So 200, almost 220 IOPS. K and IOPS, so you can see that information. Once done, everything is going to be processed and showed here. So let's just give it a few minutes. I'll show you the results of it. All right, so it's finished. And then if we check the IOPS, let's go here real quick and see if we can find that information. Scroll down. Yeah, there you go. So this is the IOPS that I was able to get on that NVMe device. So almost 200K IOPS for a single NVMe device. This is expected for this shape, right? So this is one way to test it out and make sure that you have all the performance requirements for your application. So if you design an application for high performance that needs low latency, high throughput of data, IOPS, NVMe devices is the recommended way to do it. Couple things to keep in mind again: make sure you have a backup of the data. Copy that frequently to another storage. Could be an object storage, or it could be to another block volume as well. Okay. Yeah, I hope you like it. Thanks for watching.